Hey, what's up to you all wonderful and awesome grade 10s on a new slot. Wow, it's a promotion, guys, and I hope you're going to learn more and learn extra with us as we're helping you. My name is Abram, and today we're with Tamlin. Tamlin,
How
what's
are
wrong
you?
with me? I'm tumbling now.
You're just excited for the math. That's
How are you?
I'm fine. How are you?
I'm also good.
Good.
What are we doing with the grade 10s?
Today, last week we had a look at paper 1,
Yes.
a bit of exam revision. So today is paper 2. So lots of trig and analytical geometry and all that stuff that makes up paper 2.
Nice one. So, guys, you don't have any excuse to fail. We're here 100%. We demand distinctions from you guys. Well, to join us and to send us your questions, make sure you go to our Facebook page. It's facebook.com/LearnExtra, or follow us on Twitter @LearnExtra. We've got also awesome giveaways and things that are happening on our page. But remember, guys, it's all about you. So this show is about you. So if you have any shout outs, any questions, any comments, suggestions, feel free to throw them at us and we'll read them and we'll help you.
Well, certainly.
That's what it's all
That's
about.
what we have
Teamwork. Well, let's get on here, Tom.
Okay, cool, perfect. So guys, as I said last week, we had a look at paper 1, and now we're going to have a look at paper 2 today. So just to give you a sort of overview as to what you can expect in paper 2, make sure that you, when you're studying for paper 2, the concepts you're focusing on your analytical geometry, trigonometry, that's always a big one. So make sure that we really have a good handle on your concepts of trigonometry, data handling. Okay, another way we describe that is statistics. And that's also another big one. Another one here, which I haven't mentioned here, but measurement, where you've got your volume, surface area, scale factor. Those are all concepts as well that we need to make sure you understand for paper 2. All right. So before we get going, we're going to just quickly show you the challenge question, and let's see if you can have a look at it. It is a measurement question, all right? And basically, we've said the base of a rectangular prism below has the length of 18 centimeters, as you can see on the diagram, a breadth of x centimeters, and a height of the prism is 5 centimeters. So what do we want to know? The first thing we're asking you to do is calculate the following in terms of x. Obviously, that's quite important, because obviously your answer is going to then have an x in it. Firstly, the volume of that prism. Okay, remember volume being the space that fills that prism, all right? And then what we want to do is ask you if, we want to ask you to calculate the new breadth of the prism if the volume of the prism is doubled, but the length and the height remain the same. So just playing around with changing a few of the dimensions of the prism and what happens. Okay, so there we go. That's your challenge question, guys. Give it a try, and we're going to answer it at the end of today's lesson. Okay, so as I've mentioned, what we're going to be looking at today, bit of analytical geometry, measurement in the form of your challenge question, some trig, and some data handling. So let's get onto our analytical geometry. Okay. Remember, analytical geometry is your coordinate geometry. It all gets plotted on your Cartesian plane. It's all working with coordinate points, so x and y coordinates. And just to throw it out there, just to remember, you've got your distance formula, you've got your midpoint formula, you've got gradient. Those are all the concepts that make up this analytical geometry. Okay. You do get a formula sheet, so you will be able to refer back to the formulas, but it's always a very good idea to have a firm grasp on that formula. Please don't rely on that formula sheet too much. Learn your formulas, okay? Right, what have we got? Given are the points. We've got point A, which is -3 and 2, point B, which is 5 and -1, and point C, which is 2 and P. Okay, so we're now having to calculate the following. The length of the line segment AB. Okay, so the second they're asking us for the length, we're looking for the distance. Okay, so we're referring to our distance formula over there. So we're going to start with our distance formula. The distance from A to B squared, because that's the formula, AB squared, is equal to x1 minus x2 squared plus y1 minus y2 squared. Okay. Remember that formula, where it comes from, it's derived from Pythagoras. Okay, so if you sort of recognize the format of it, that's where it comes from. We came up with the formula from using Pythagoras. Okay, a little hint to you guys. If we're looking for the distance from point A to B, let's label this. I'm going to call this over here x1, and I'm going to call that point over there y1. Point B, I'm then going to refer to as x2 and y2. It's just safe because probably your biggest errors here happen as silly errors, where you substituted the wrong value into the wrong position. So just be careful of that as a caution. So label points, just be extra careful there, okay? All right, so let's do it. We got AB squared, which is equal to x1, which is negative 3, minus x2, which is 5. That's being squared. Plus y1, which is a 2, minus, now take notes over here, we're minusing, but there's also a negative 1. So can you guys see I've kept that in a bracket over there? And I'm going to just sort that out in the next step. Okay. So we've got AB squared, which is equal to, okay, inside my first bracket, negative 3 minus 5 is negative 8. That squared is 64. In my second bracket, now these two negatives over here, let's just make it green so we can see those two negatives over there obviously are going to become positive. So I'm sitting with 2 plus 1, which is 3, and 3 squared becomes 9, okay? So we're sitting with, okay, I'm going to have to write it over here, AB squared, which is equal to 64 plus 9, that is going to be 73. Okay, and the last thing is that I don't want to know the distance of AB squared, I want the distance of AB. So the final step, please remember, is to square root it, okay? So therefore your distance from point A to point B is the square root of 73. The reason we don't put plus minus, okay, because remember when we do put a square root over a value, we should write positive and the negative, but we're talking about a distance, and a distance is a positive value. It's an absolute value, so therefore there is no negative there, okay? So that's why we'll leave it as just positive root 73. If the question requires you to leave your answer in surd form, okay, I'm sure your teacher has explained to you that surd form would mean leaving it like that, inside the square root sign. However, if the question requires you to work it out to 2 decimal places, then obviously what we'll do is put that into our calculator and we'll work out the decimal answer of that. So read your instructions as to the way they want you to give the answer. Please be careful of that. The way they're asking is the way we expect to see it, okay? All right, so there we go. That's using our distance formula. Now it says that we're looking for the coordinates of M, which is the midpoint of the line AB. Okay, so let's quickly just give ourselves a little bit of space here. I'm going to take that away from there. And let's just write it over here for now. So we said that AB was the root of 73. Okay. The midpoint, okay, midpoint is obviously the halfway mark, all right? So the formula that we need to know for midpoints is as follows. The midpoint between point A and point B is going to be as follows. x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Now, can you see that I've written it as a coordinate point, okay? Because that's what we're looking for. We're looking for the coordinates of the midpoint, of the halfway mark between 2 points on your Cartesian plane. So when you're working it out, that's how we're giving it as a coordinate point. All right, so therefore we're going to say x1 we knew was negative 3. Guys, I'm going to write it over here. We've got negative 3 plus x2. x2 we said was 5, and we're going to put that over 2. And y1 was 2 plus y2, which was negative 1. Again, there's that negative, so just keep it in a bracket, and it's over 2. So therefore, that's going to give me negative 3 plus 5, that's 2 over 2, which is 1. And I've got 2 minus 1, which is 1 over 2, so therefore a half. So there's the midpoint. The halfway mark between point A and point B was 1.5. Well, x coordinate is 1, y coordinate's a half. Okay, easy formula to work with, but just make sure you practice all the different variations, the different ways it can be asked, because we can mix it up a little bit. So just make sure you understand that nicely. All right, and the last one, calculate the value of P. Okay, so remember point P was over here. It was part of, I'm going to put the P over there so it makes more sense. It's part of the coordinates of point C, okay? And they've said find the value of P if the gradient from B to C is 2. Okay, gradient, different formula, all right? Remember from linear functions, straight line graphs, to work out the gradient, okay, the gradient from B to C, we say the following. The change in y over the change in x. All right, so y1 minus y2 over x1 minus x2. All right, and we go back to our points. Point B, let's just make sure we've got our points over here. It makes it a bit easier. Point B was 5 and negative 1. 5 and negative 1, and point C was, so let's just make sure we've got it right, 2 and P. 2 and P. Okay, so we know that the gradient, now they've actually told us the gradient. You guys agree we actually have the gradient over there. So when we do our y1 minus y2 over x1 minus x2, we actually know what it's going to be equal to. They've told me that the gradient is 2. So I hope you guys can all see how this little equation is going to be built around to help us solve for P. So therefore we're going to say the gradient from B to C was 2. y1, let's call this over here x1, y1, x2, y2, okay? So y1 minus y2, do you guys all see that y2 is actually the value of p over x1 minus x2? Okay, and what we're now sitting with is just an equation to solve. We're going to solve for p here. So let's tidy up just a little bit. Negative 1 minus p, that's going to end up being 3 in the denominator. Instead of dividing by 3 on the right-hand side, I'm going to multiply by 3 on the left-hand side, giving me a 6 equals negative 1 minus p. Minus p. If I bring that over, I'm going to have 7 equals negative p, and obviously I don't want negative p, I just want p, so therefore negative 7 equals positive p. Okay, right guys, so that's 3 quite straightforward examples of applying your distance, your midpoint, and your gradient formulas. So we're definitely going to expect something along those lines, but we also can definitely expect the teachers to just mix it up a little bit. So let's take an example that just makes it just a little bit more interpretive, okay? So we've got a triangle, ABC, which has the coordinates of A, negative 4 and 2, B, 1 and 2, and C, which is negative 1 and 6. And AC is 5 units. So guys, that's the distance from point A to point C, okay? All right, here's the question. If D is the point XY such that point E, which is the coordinates of 2 1/4 and 7, is the midpoint of CD, determine the coordinates of D. So that sounds like a bit of a mouthful. So now if you have a question like that, just take a second, read it through carefully again, and just think about what they're saying. With analytical geometry, a diagram can really help you out. So if you're a bit stuck, draw the picture, plot the points, and see if we can figure out more or less what's being asked of us here. So if I had a x and y axis, okay, and we had the points. Let's just see the points again. A was, sorry, we're talking about lines C and D. So C was negative 1 and 6. So let's just more or less just plot it. We're not going to be exact, but there's point C. And point E was 2 1/4. So, okay, let's see. If that was 1, let's make that 2. So let's make that 3. So 2 1/4, yeah, let's just make it around about there. And 7, okay, 7 is going to have to be slightly higher than 6. So let's estimate that point E is up there somewhere, okay? And we are now saying that point E is the midpoint between C and D. So therefore, I'm going to have to run into my writing a little bit here, but point D is going to have to end up being somewhere around about there, okay, where it's actually going to be the other point where E is the halfway mark between those 2 points, okay? So as you can see, sometimes just by drawing it, it kind of helps to make a bit more sense of what it's actually saying. So in this case, I have point C. I know that the coordinates are negative 1 and 6. And I have point E. Okay, now they've given this to you as a mixed fraction. We don't want to leave that as a mixed fraction. Write it as an improper fraction, which is going to be 8, 9 over 4. Okay, 9 over 4 and 7. Those are the coordinates of point E. It's point D that we don't know. There's our problem over there. There's X and Y, and we have no idea right now what those coordinates are. But what are we going to rely on? What are we going to turn to? Okay, we're talking about midpoint. So midpoint, guys, is the formula that you need to go to. All right? So the midpoint formula said the midpoint from C to D is calculated by taking x1 plus x2 divided by 2 and y1 plus y2 divided by 2, and we can work out the midpoints. But the thing is, we already have the midpoints. It's the other coordinate that we don't have, okay? So in this case, guys, what we're going to do is we're going to talk about just the x coordinate first, and then later we'll talk about just the y coordinates. So what is the x coordinate of my midpoint? Okay, the x coordinate is 9 over 4, so this is what we're going to say. 9 over 4 is equal to x1, which is negative 1, plus x2, which is x, over 2, all right? And we have an equation to work with, all right? So we can actually solve for x now. So what can I do? I'm going to leave that as 9. I'm going to times by 2, because that's what I do to the bottom, I do to the top to find an LCD. So therefore, I've got negative 2 plus 2x. The denominator will fall away. That's going to come over to become 11 equals 2x, and 11 divided by 2 equals x, okay? So 5.5 is equal to the x coordinate of the midpoint, okay? That wasn't too bad. And we're going to do exactly the same thing for the y coordinate, all right? The y coordinate, let's do it in a different color. The y coordinate was 7, all right? So we say the y coordinate, which is 7, is equal to y1, which is 6, plus y2, which is y, over 2, all right? And that again gives us an equation to solve. 7 times 2 is 14, 6 plus y. If I say 14 minus 6, that is going to leave us with 8, which is equal to y. And that's the coordinate. So point D is the coordinates of 5.5 and 8, which if we look back to my diagram, if the x coordinate's 5.5, if we sort of look at the rough plot that we've done, we can see that it would actually make sense, that everything would fit nicely there. So guys, please go practice questions like that, because we definitely like to throw those in there where you actually have the midpoint and you've got to use that to work out one of the missing sides of either side of that midpoint, okay? Right, so there we go. That's a bit of analytical geometry. I think we're going to have a short break and then have a look at trig.
Yes, Timlin. And during this break, guys, you do have the challenge question. Make sure that you tackle it and get your notes right now. If you want all our notes, go to learn.mindset.co.za. You're going to get all the notes that we have for you guys. Stay tuned. Welcome, Mindsetters. Now, I just want to urge all of you guys, if you just joined us now, make sure that you get your notes and get your pen and paper and start writing the notes, because what Tamlin is giving you, it's a great exam resource that you're going to need every day, guys. Whenever you're writing your exams, these will come in very handy. And apart from that, I also want to challenge you to send us your questions on facebook.com/learnextra or on Twitter @learnextra. We're here to help you learn more and learn extra. Tamlin?
There we go. And just don't forget, grade 10s, that everything that you are doing here is literally just laying the foundations for what you guys are going to do when you write those grade 12 exams. So all of this stuff is really just starting to build on that knowledge. So it's so important that you understand it now. So any questions, and you must just shout. Right, so let's have a look at some trig, okay? So we learned during the year, when you learned about your trigonometry, we learned that we have ratios such as sine theta, cos theta, and tan theta, okay? We also learned the reciprocals, cosec, sec, and cot. And really great things, this is theory, okay? It's stuff that you need to learn, okay? If you don't believe it, maths is a studying subject, okay? You do actually have to learn this stuff. Because it's required that you know it, okay? Sine theta, the ratio of sine theta, if I'm working in a right-angled triangle, okay, this year in grade 10, you will only work in a right-angled triangle. Next year, we'll push you a little bit harder than that, but for now, this is what we've got. So you've got a right-angled triangle, and what you need to do is you need to identify in that right-angled triangle from a reference angle, okay? So you have to go from a particular viewpoint where the opposite side would be, where the adjacent side would be, adjacent meaning the side next to the angle, and then your hypotenuse, that one never changes, that's always opposite your 90 degrees. So just to illustrate what I mean, if I've got an angle of 53.14 degrees, if that was my reference angle, my point of view, the angle opposite that, the side opposite that angle is going to be your side AB. The side adjacent to that angle is going to be your side BC. And then the side opposite your 90 degrees, that's going to be your 20 meters. So you can see that that would be your opposite, your adjacent, and your hypotenuse. However, if I were to, let's take those away. If I were to take it from another angle, so let's just for now say I was working from this angle of A, all right? What happens now is that the perspective changes. So now what would happen is that that side would then become the opposite side, this would become the adjacent, and that would remain the hypotenuse. So please practice that, guys. It's just identifying from your angle where is the opposite, the adjacent, and the hypotenuse. Really, really important, okay? All right, but based on this question, what are they asking me? So we've got angle C, which is 53.14 degrees. The length from A to C, which we know is the hypotenuse, is 20 meters. And what they're asking us for is the length from A to B. So we're looking for this length over here. Okay? So guys, a good starting point is that if you have a right angle triangle, you've got an angle, you've got a side, and you're looking for another side. Okay? A good starting point would be saying this. Take your unknown side, so the side that you are looking for, over the known side, okay? So what do I mean by that? The unknown side in this case is the opposite side. It's the one that I'm looking for. The known side is the one that I already have, which is my hypotenuse, okay? Now, if that's the case, opposite over hypotenuse should ring a bell, because opposite over hypotenuse is the ratio of sine, okay? So therefore, we can actually say that sine of theta, but now in theta, I have the angle. I don't just have theta, I've got 53.14. So sine of 53.14 degrees is equal to the unknown side that we're looking for. That was our AB over the known side that we've got, which is our 20 meters. Okay, there we go. So now what we have to do is take the 20 meters. Instead of dividing it on the right-hand side, I'm going to multiply it on the left-hand side. Okay. And that leaves me with AB. Right, so now we are going to have to pull out our calculators. Unfortunately, that's not a special angle that we can use. So let's do that over here. And we type in. So we've got 20. So it's just, and I've gone and closed it. I'll have to reopen the calculator just now. You guys can do it on your calculator. So you're literally typing in 20 sine of 53.14 and equals, and you're going to get your answer. So try it on your calculators. When I get mine up again, I'll give you the answer again, okay? All right. And then what they've said is express BC in terms of tan 53. Okay, so now we now know the length of AB. Okay, now that's a known side. All right. So now what they're wanting us to do is to express the side of BC in terms of, what did they say? In terms of tan 53.14. Tan is the ratio of your opposite side, which is AB, over your adjacent side, which is BC. Okay? So tan from the angle of 53.14, okay, is equal to the opposite side, which is side AB. Okay, you guys will now have a length for that, so actually have a value for that, over the side of BC, which we don't have a value for. And what you now need to do, the question says express BC in terms of, which means that you need to get BC on its own, okay? So I'm going to have to manipulate it a little bit. Instead of dividing by BC on the right-hand side, I'm going to multiply it on the left-hand side. So BC multiplied by tan of 53.14 is going to leave me with the length of AB, which again, you guys have that length at this point. And then finally, we're going to get BC on its own by taking the length of AB and dividing it by the tan of 53.14. Okay, and that will give you the answer that you're looking for, the length of BC in terms of tan of 53.14 degrees. Okay. All right, guys, so I hope you're understanding that. The ratios, the basics of trig, which is what you're doing this year, it's essential that you really get a good, solid grasp on that. So when you're practicing, you don't have to go and hunt out the most difficult examples. Just go and find those solid ones where you're practicing your ratios, understand the solid concepts so that when we build on it next year, it's really, really clear. Abram, I'm really going to need the calculator for the next examples. I think we might have to take a short break.
All right.
Is that all right?
It's fine. It's fine. Let's take that break. During
Okay.
this break, guys,
2
let me
minutes.
remind you that you do have a challenge question that is posted for you on our Facebook page as well as notes. And if you don't see them, go to land.mindset.co.za. We'll see you after this very, very short break. Welcome back, awesome mindsetters. Now, there's a big shout out to Sizwe SIM card Pagati. This guy's middle name is SIM card. So I hope you've got your SIM card on, and thank you for watching our show. And because you said I should call out your name, holla at you. Thank you for watching the show. Tamlin, are
All
we
right.
good?
Yes, we're good. We've got the calculator back.
Awesome.
Unfortunately, for this kind of thing, unless it's special angles, you do need it, okay? All right, so we've got a really cool picture over here. Okay, this is where maths becomes so exciting because you can actually see how it gets applied in real life, okay? We have got a diagram which is a rough unscaled plan of the front structure of a house and a garage. Okay, so I hope you guys can see that diagram nice and clearly. And what the first question is asking of us is calculate the value of h. Now I know it's relatively small, so I'm going to highlight it for you so you can see it. H is this little distance between these two arrows over here. Okay. Now, okay, so they're asking us to calculate. They're asking us to calculate this this tiny little height, that tiny little space between obviously the roof. The roof of the garage and the pitch of the height of the roof of the house, okay? So what we need to do is this, guys. We actually are going to focus in on this right angle triangle over here. It goes all the way from there to there, okay? And then the height of h, which is that little piece over there. So it's a little right angle triangle. So what I'm actually going to do, just to make it look a bit easier to work with, is I'm going to do that. Okay, so we have got this distance over here. They've told us that the pitch is 3 degrees, so that's only 3 degrees over there, all right? We know that the distance of the garage, or the width of the garage, is 2.9 meters, so that's 2.9 meters over here, and here's the h that we're trying to work with, okay? And the diagram is quite small, so I've just magnified it into a bigger triangle to work with. So how would we do that? Okay, so we're going to apply what we did in the previous question where I'm going to take the unknown side. Okay, so first of all, let's identify the side opposite the angle. There's my opposite side. Here's my adjacent, and here's my hypotenuse. Okay, so the unknown side is the opposite side over the known side, which is the adjacent. And if we recall our ratios, we know that that's our ratio of tan theta, okay? So therefore, this is what we're going to do. Our unknown side was a height of h. The known side was 2.9 meters. And it's equal to tan of, and the degree was only 3 little degrees over there, okay? So now we have to work out what that h is going to be. So we're going to take h, leave it on its own, and say 2.9 multiplied by tan of 3 degrees, okay? Right, so here we go. We've got 2.9 multiplied by tan of 3 degrees, and we get a 0.15. So let's round it up to, let's do 2 decimal places, 0.15 meters. Okay. So h is equal to 0.15 meters. Okay. Tiny little inclination that 3 degrees was so small, so it would make sense that h is not a very big distance at all. It's a tiny little gap there. Okay. All right, then now that we've got that, now they're asking us to calculate the pitch of the house roof. So we're looking for this here, okay, the pitch there, shown as theta. So what we're going to have to do is I'd sort of focus in on that 90-degree triangle that we've got in the roof of the house over there, and now decide how we're going to find that value of theta, okay? So this time it's slightly different because we are working with a right-angled triangle. We've got this right-angled triangle, okay? And this time, what's unknown is the angle, all right? We actually have two lengths. I have the length of 2.8, and I have the length of 1.4. So the thing now is to just work with it slightly differently, that we're working with the angle and not a side, okay? So in this case, it wouldn't be necessary to do your unknown over your known because both sides are known, okay? So all you're really needing to do is just to try and identify the ratio that we have of the known sides. This over here was my opposite side. This was my hypotenuse, okay? So the ratio of opposite over hypotenuse was sine. So therefore we've got sine theta. I'm actually going to just take that equals away. It shouldn't be there. Sine theta, which is equal to the opposite side, which is 1.4, over the hypotenuse, which was 2.8, okay? So that's what we've got, and now we're trying to find the size of theta, okay? So we're going to have to move the sign away from your theta, all right? And the function on your calculator that's going to do that for you, if you look at your sine button, if we press shift sign, do we see we get the sign to the -1, okay? That's your dividing by sign. You're getting sign over into the other side, all right? So we're going to say theta is equal to sine to the -1 of your ratio of 1.4 over 2.8. Okay, and that we're going to let our calculator help us out with. So therefore I've got the fraction of 1.4 over 2.8. And we're getting 30, okay. So there we go. Theta works out to be an angle of 30 degrees. All right, so there we go. That's the angle of inclination, or the pitch of your roof, okay, the degree at which it's inclining, okay. Alrighty, and then we're going to see what else we want. Calculate the width of the house. So we're looking for the length from A to B, all right? So that distance over there. Well, we would have to say, okay, well, your house is this this rectangular shape in front over here, and what we know about a rectangular shape is that the length at the bottom would be the same as the length at the top, okay? So if I've got this right-angled triangle, and I know two sides of that right-angled triangle, well, I could find the distance of just this half of the rectangle over there as the base of that triangle, all right? Two ways in which we can actually do it, grade 10s. Either we can use Pythagoras, okay? We can take your hypotenuse squared is equal to your vertical side squared plus your missing side of that half of AB squared. Or we can actually use trig again, okay? So just to make it interesting, because I think we all know how to do Pythagoras, I'm going to use trig again just to show you how we can get that, all right? So the unknown side from this angle, which by now, guys, do you agree with me? We've worked out that that's 30 degrees, okay? So I'm going to use that now. The unknown side in this triangle is now your adjacent side. So if I take my adjacent side, and let's put it over the known hypotenuse. If I put the adjacent over the hypotenuse, that's going to leave me with the ratio of cos theta, all right? So therefore, if I take cos of 30, so we're working out this question over here. If I say cos of 30 degrees is equal to the adjacent side, which I don't know, over the hypotenuse, which was 2.8, okay, then we're going to say 2.8 multiplied by cos of 30. Now, a very possible way of them asking you this is to say to do it without the use of a calculator, all right? And I hope you would recognize that the reason why they could ask you to do this without the use of a calculator is because, in fact, 30 degrees is a special angle, all right? Special angles need to be learnt, okay? So just to remind you, cos of 30 is actually root 3 over 2, all right? So let's see, that would mean that I've got this. I've got 2.8 multiplied by root 3 over 2, and that's going to give you your length from your adjacent side. Let's just multiply that by, so that answer times by 2.8. So that's giving us, as a decimal, 2.42 meters. And just don't forget that obviously that's just half of the roof. That's just half of it. We're going to double that. So we're going to times that then by 2. 2 times by the answer of 2.42. 2.42 is going to give you the total length from A to B. And obviously that's going to give you 4.84 meters as your length from A to B. Okay. All right, guys. So really practical example of actually how you can apply that trigonometry and how you can actually break a shape into right-angled triangles and then use your ratios from there. So nice example. Lastly, here it says, what would the impact on H be if the pitch of the garage roof was changed to 15? I'm not going to do the whole thing just in terms of time, but let's think about it. This was 3 degrees. That small little angle was only 3 degrees. So if that 3 degrees was increased to 15 degrees, what do you guys think would happen to H, this little distance of H over here? Well, I hope what you're all saying to me is that 3 degrees being such a small little angle would create a very short, a very small length of H. Obviously, it would make it increase quite substantially. But you would follow exactly the same process. So using it, see if you guys can work that out and work out what the new height of H would be with an angle of 15 degrees and not 3 degrees. Okay. Right, there we go. So that's a nice question on some trig. Go and practice your trig. It is essential that you guys have a good understanding of it this year. So please make sure that you've really worked on that. All right, now comes, this is the easy part of your paper too. Everyone likes a bit of stats. It's a nice section to sort of just take your time and get some good marks in. So let's have a look. It doesn't come without its theory, okay? We've got to learn the terminology. You've got to really know your theory with stats. So also a word of warning, don't take it too lightly. You do need to study the section quite thoroughly. Let's see what we've got over here. The ages of people in the Jackson family are as follows. Okay, we've got everyone from 63 all the way through to 34, a 32, a 27, a 35, okay? Determine the mean. Okay, so I hope by now we all know exactly what the mean is. The average, okay? And the average, the symbol that we use for our average is our little X bar, and that's the sum of all the values that you have divided by the number of values that you have, okay? So to work out our average, we're going to take everybody's ages together, add them up, divide by, how many we got here? 2, 4, 6, 2, 4, 6, 7. We've got 7 people there, so we would divide by 7, and we would get our average, all right? So just to show you how to do it using your calculator, all right? Let's see how we go. Most of you, I'm sure, know this by now, but let's give it a try. So we press mode, and we press 2 for stat, and we press 1 for variance, okay? What you'll notice over here is that the calculator's actually got a frequency column that's been added on there. Just so you know how to get rid of this, because I think it is important to know. If you're stuck with that, guys, this is what I want you to do. You press shift, you press setup, okay? We go down to where it says 3 for stat, and it asks you if you want the frequency on or off, okay? So in this case, I don't want the frequency on, so I'm going to press 2 for off, and then I can go back to just my mode, my stat, my 1, and now you'll see that, in fact, just that 1 column is there. So just a handy bit of information there for you if you're using your calculator. Okay. Right, so what we're now going to do is we're going to type in all the data. So I've got an age of 63. I've got an age of 32. I've got an age of 34. I've got a 64. I've got a 32. I've got a 27. And I have got a 35. Okay. Now that you've put all your 7 ages in, all right, this is the next step, guys. We press AC, Shift 1, all right, AC Shift 1, and then you get all your different options over here. The one we are looking for is your variance. We're looking for number 4. All right, so we press 4. And can you see that number 2 is the same symbol that I've drawn over there? All right, so we're going to press number 2 and equals. All right, and there we go. The average is 41. All right, so some of you might have done that manually, added them up. The value in doing it on your calculator, I think, is if there's a lot of numbers, it saves you a little bit of time. So there we go. All right, so 41 is our average. Okay. Average age, okay? Although, it's actually quite interesting, although most of the people are actually below 41, it's these two guilty parties over here that are causing the average to be higher than, in fact, what most of the people are in that group. Okay, so it's skewing the data a little bit, all right? Determine the mode. Remember, your mode is your most common occurring piece of data or value in your data set, and 32 is your most common occurring value, so 32 is going to be your modal age. The median, all right, the median's important because what you have to first of all do is you have to arrange your data from lowest to highest, okay? The youngest person here is 27, followed by a 32, two 32-year-olds, okay? Then we have got a 34. We have then got, so these guys are all out. We've used them. We've got a 35-year-old. And then we've got a 63 and a 64. Okay. So median, middle number, I've got 7 items. So if I count 1, 2, 3, 1, 2, 3, we land up with our number of 34 bang in the middle over there. Okay. What am I seeing in terms of my my average and my median? The average is slightly higher than the median, okay? So therefore we know that it's being you're being skewed on that side. So you've got let me get this right. You've got your mean, which is greater than your median. So you've got a positive skew, okay, on your data. And then your upper quartile, okay, remember now that you're working with, so now you've got your Q2, you've divided it in the middle. Q2 is another way of referring to your median. You've got a lower half of your data and you've got an upper half of your data, all right? The upper quartile is basically the halfway mark of your upper half of your data, and in this case it's going to be 63. So your upper quartile is 63. Okay, so those are pretty straightforward, but obviously we do need to know how to work those out. And let's see if we can now apply it to something a little bit more tricky. Yes?
Can we do the challenge question?
Yes. Are we going to run out of time?
I'm thinking of time.
Oh dear, okay, well let's do this and let's see how we go. Okay, if we don't get back to stats, guys, as I said, it's something that you can work through quite nicely on your own, but don't neglect it. It is a section that does require a bit of work, so just spend some time, as well as trig and analytical and all the others, okay? All right, our question, we had a prism, we had a rectangular prism, and we had to calculate, first of all, the volume, all right? It did say in terms of x, okay, so obviously just watch out when they say that in terms of an instruction, they're just saying that your answer is going to have an x in it as part of your solution, okay? What have we got? Volume. That's all the space that's inside your prism, okay? When you're working with a prism, it doesn't have to only be rectangular, it can be triangular, okay? When you're working with a prism, you want to take the area of your base, okay, whether it be triangular, circular, rectangular, area of your base times by the vertical height of your shape. That's going to give you volume, all right? So you don't have to sit and learn every single formula off by heart. If you can just remember the basic structure of that formula, area of base times height, that's going to give you volume. So in this case, I've got the area of my base, which is going to be a rectangle, so it's length times breadth times by the height of my shape, okay? So what have I got? I've got length times breadth, all right? So my volume is going to be equal to my 18 times by my breadth of x times by my height of 5, okay? And if I multiply those together, 18 times 5, we get 90, all right? So therefore 90x, okay, my units are centimeters, so this is important, centimeters cubed, because remember every time you're working with volume, it's a cubed, whatever your units are. All right. Okay, so there we go. I hope you got that part right. That wasn't too difficult. Then it says to us, the new breadth of the prism, if the volume of the prism is doubled, but the length and the height remain the same. Okay, so we know that the volume at the moment is 90x centimeters cubed. So if I were to double that, all right, so if I were to times that by 2, the new volume would be 180x as centimeters cubed as a volume. So, okay, if the volume is doubled, but the length and the height remain the same, so the length is 18 and the height is 5. So 18 and 5 are going to stay the same, but it's the breadth that we're trying to calculate as a new length. So let's see, 18 times 5 we knew was 90. So 180x divided by your 90 is going to give you your new breadth. And if you divide that, so you'll end up with 2x as your new breadth. Okay, there we go. So that starts implying a little bit of scale factor, all right? If you just double one of your lengths, then your volume just doubles, okay? But remember with scale factor, just seeing if you have a few minutes, let me talk about it very quickly. If you're talking about scale factor, if I were to increase every length of this rectangular prism by 2, okay, so I'm doubling everything, would the volume just double? Well, obviously from the example that we've just done, it wouldn't, because in the previous example, all I did was I doubled the length of my base, okay? And by doing that, it only doubled the volume, just by doubling just one of the dimensions. So if I doubled all 3 of the dimensions, what would happen to my volume? I would have to multiply it by whatever the scale factor is. In this case, 2, if you're doubling it. You would multiply it by the scale factor cubed, all right? So if you doubled the length, the breadth, and the height, I would then have to take my volume and I would have to multiply it by 2 cubed, which is actually 8, okay? So that's interesting. So you've got to know that, guys. That's also important as part of your syllabus. If you are doubling your dimensions, and we're talking about surface area, all right, for surface area, you multiply your surface area by your scale factor squared. All right, so if my scale factor was 2, then I would take my original surface area and I would times it by 4. Okay, so guys, you need to know that. Please make sure you have worked on that at home and understood that quite nicely. All right. Okay, so that's how did we do? Did we have people who got that right?
Yes, we do. Plenty of them.
Oh, good. It wasn't very difficult.
Although others got their own answers, but I think they were close to that.
They were good.
Yeah,
Okay,
for giving
fantastic.
it a try.
Well done, guys. And obviously, as part of measurement, you've got your pyramids, okay? Make sure you learn your volume and your surface area of pyramids. Spheres, okay, your ball shape. Cones, all of those are new shapes that we start working with the volume and surface area of. So just make sure that you have worked with those and you understand those nicely, okay? What I'm going to do very quickly, let me just talk through for a minute about the statistics question we didn't get a chance to have a look at. We've got a histogram. They're wanting to know the range. Remember, grade 10's range is your highest value minus your lowest value. So your highest minus your lowest, that's going to give you your range, okay? Modal group, remember when you're working with grouped data, you don't have individual values, so you have to work with the class interval. So your modal group in that case would be the one with the highest frequency. Median values, okay, so now you would have to work out the halfway mark of the data over here and count into which interval the median would fall. And then lastly, unfortunately, I don't have time to do it with you, but your estimate mean. Guys, please go practice that. Work out the halfway mark times by the frequency, all added together, divided by your total. Okay, so lots of formulas. Paper 2's got lots of formulas, lots of theory. So you just have to go and get down to those books. All right.
Thank you so much, Tamlin. We really enjoyed it.
It's a pleasure.
All the best to you guys, and thank you for tuning in. And remember, if you still need help, we're here to help you guys every day. Otherwise, thank you so much to M10 SA Foundation for proudly sponsoring the show and the Department of Basic Education for endorsing this program. We love you and peace.